In this chapter, we're going to look at how we can use trigonometry to find the area of a triangle and also to use it to find angles or sides of non right angled triangles. So, first of all, what is the area of a triangle by traditional method? We know that the formula for the area is half into base into height. So, if you look at this triangle, what is the area? The base is, in this case, 18, and the height, as you can see, is 6. So the area is half times base times height, or half times 6 times 18, which is 54. But what if you had a triangle in which you did not have a right angle? You just were given two sides, say, in the same triangle, 18 and 12. Now, if I told you that the area was equal to half of side 1 times side 2 times sine of the included angle, or half times 12 times 18 times sine 30, as you can see here, if you calculate this, you will still get 54. Now, how did we get this particular formula? This is what we will look at later in this lesson. Just to remind ourselves that the height in a triangle is always the perpendicular height. So in each case, you can see that a perpendicular line is drawn from the vertex at the top, if you're using that, to the base, and that is considered as the height. So let's go into how to find an area of a triangle using trigonometry. Consider a triangle ABC. Note that the side opposite the angle A is denoted by lowercase a. The side opposite the angle B is denoted by lowercase b. The side opposite angle C is denoted by lowercase c. Now area is base times height times half, or half times A times H in this particular triangle, A and H. Now sine C, as you know, is opposite by hypotenuse, so it's H by B. So H is B sine C. Similarly, sine B is H by C, so H is C sine B. But since we have two expressions for the same quantity H, we can substitute each of these into the expression for area, which is half times A times H. When you do that, you will get half times AC sine B. That is when you substitute H as B sine C into the expression H in the area expression, you get half times A times C sine B, or half AC sine B. Using a similar argument, you can show that area is half BC sine A. So in any triangle ABC, the area is half AB sine C, or half AC sine B, or half BC sine A. Do you notice a pattern here? It's as simple as ABC. Remember the order: ABC, ACB, BCA. Note that the third letter is capitalized. Why? Because when you put them into this formula, sign of the capital letter indicates its sign of an angle. Also note that the angles here are the included angles. That is, the angles encased by the two sides. So for example, consider the area half AB sine C. So here angle C is the angle encased by the sides A and B. That's therefore angle C is the included angle for the sides A and B. Let's look at the correct way to label a triangle sides and angles. So when you have any triangle ABC, then remember the opposite sides are the lowercase letters of the angles. It does not matter which letters you choose. You could choose X, Y, Z. Just remember that the opposite sides are the lowercase letters of the angles. Let's do an example. Find the area of a triangle given that The two sides are 28 and 25 kilometers, and the angle here, which happens to be the included angle for these two sides, is 82. Remember that in any triangle, half AB sine C is half AC sine B is equal to half BC sine A, and that's the area. So here are four steps you can use to solve for area. Step 1, label the angles. Step 2, label the opposite sides. Step 3, write down what's given and what is to be found. Step 4, plug into the formula for area and solve. And so when we do that, you can see we first label the triangle, and it doesn't matter which order you use or which letters you use. But whatever letters or order you use, make sure that the opposite sides are labeled with the same letter. Step 3, write what's given and what's to be found. Step 4, use the formula that's appropriate for what's given. For example, here you're given A and then small lowercase b and c. So you can use the formula area is half BC sine A. You choose the appropriate formula. Plug into the formula and solve as one shot with the calculator. In this case, you get 347. Use the appropriate units with the square on the unit to indicate area. So 347 kilometers squared in this particular case. Here's another example of the area of a triangle. You can pause the video to study this example, but we're going to go on now to the law of sines. The law of sines follows very easily from the law, the area of triangles expression. We know that in any triangle ABC, half AB sine C is the same as half AC sine B and half BC sine A. Let's do a simple mathematical operation of dividing all the terms by half ABC. If you do that, you'll find that in each case, there are terms that cancel out, giving you sine C by C is equal to sine B by B is equal to sine A by A. This is an interesting new expression relating the angles and the sides with their signs. This is called the law of sines. Once again, very simple to remember, as easy as ABC. An alternative expression for the law of sines is to reciprocate each term. So sine C by sine C is equal to B by sine B is equal to A by sine A. Let's use the law of sines in an example. Use the law of sines to find the value of x in this particular triangle. Remember, in any triangle ABC, C by sine C is B by sine B is equal to A by sine A. The steps to solve problems on law of sines are similar to the steps to solve problems on area. So here's what we can do. Label the triangle. Remember any letters, any order, but make sure that the opposite sides are labeled appropriately. Step 3 would be to write what's given in terms of the labels you use. Here A is 108, B is 48, and lowercase b is 9. You want to find A. So if you want to find A, you will need to use an expression that includes the angle A. So the expression that we can use is A by sine A is equal to B by sine B. Why did we choose B by sine B? Because we know both lowercase b's value and the value of uppercase b. Plugging into the formula, you get x by sine 108 is 9 by sine 48. Now, move the terms across to leave x on its own, or in other words, multiply both sides by sine 108. You get 9 sine 108 over sine 48. I recommend you plug this into the calculator as one shot. You don't have to write the steps of solving this separately, and you get an answer which, when rounded to the nearest tenth, is 11.5 centimeters. And now it's up to you to practice. So use the textbook and you do exercise 10E, do the problem sets 1, 3, and 5, That's on the area of triangle. And then do exercise 10F, 1, 2, 3A, 4A, and C.